Hello everyone, welcome back to our course series on Python for data science. In this video we will discuss about reading data. We will discuss about different file formats commonly used from the data science perspective. Though we will be using CSV or Excel and text file format mostly for this course. So, let us first discuss about what is file format. So, the different data formats refer to the various ways in which data can be structured and stored. Here are some common data formats. Structured data. This format organizes data into a well-defined schema, such as tables in a relational database or CSV files where data is arranged in rows and columns. Unstructured data is data without a predefined structure, like text documents, images, videos, and audio files. This type of data requires special processing techniques for analysis. Semi-structured data falls between structured and unstructured data, containing some organizational elements but not conforming strictly to a schema. Examples include JSON, XML, and log files. Binary data, data stored in binary format, often used for efficiency and to preserve data integrity. Examples include images, videos, executable files, and database files. Compressed data is data that has been compressed to reduce storage space or transmission time. Common compression formats include zip, gzip, and bzip2. Database-specific formats. Each database system may have its own data format, such as MySQL's .SQL dump files, MongoDB's BSON format, or SQLite's.SQLite database files. Text-based formats includes formats like comma-separated values, tab-separated values, JavaScript object notation, extensible markup language, and YAML, commonly used for data exchange and storage. Hierarchical data formats, HDF, designed for storing and organizing large amounts of scientific data. HDF formats like HDF5 are used in fields such as astronomy, physics, and engineering. Parquet and Avro, data serialization formats designed for big data processing, optimized for efficient storage and processing in distributed systems like Hadoop and Apache Spark. Protocol buffers called as Protobuf and Apache Thrift, binary serialization formats used for efficient communication between systems, commonly employed in microservices architectures and network communication protocols. Each data format has its own advantages and use cases, and choosing the right format depends on factors like data structure, size, processing requirements, interoperability, and storage considerations. Since this course is focusing towards data science, so we will be working mostly with comma-separated files or Excel sheets. Alright, before diving into importing data, let's talk about setting the stage, which means loading up the necessary tools. The first tool in our toolkit is the OS library. So, we import the OS library with a simple command, import OS. Why do we need OS? Well, sometimes, that data might be residing in a different folder on your computer. So, OS jumps in to help us change the working directory, making it easier to access our data wherever it's stored. Next up, we bring in the Pandas library. When it comes to working with data frames, think of data frames as organized tables where each row is like a sample, and each column represents different variables. So, importing Pandas as PD becomes important to access the data in structured manner. Now, why PD? Well, it's simple shorthand. Whenever we want to use a Pandas function, we just have to type PD followed by a dot and then the function name. Lastly, with the OS library, we can use its chdar function. This function is our ticket to navigating through folders. Just give it the path to your file. So, now let us see how to read a CSV file. pd.read_csv is the command is used to read any CSV files comes from the package called Pandas, and we are saving the same into Pandas object called as df representing as data frame. Please make a note that link to access this data is given in description box. Alright, let's dive into the details of your data. First, We use df.head function, which is used to quickly examine the structure of your data frame, including column names in the first few rows of data and check for missing values or anomalies in the initial rows and also to get a sense of the data types and format used in the data frame. So, in this case you've got several variables in your dataset, starting from index to species. The index is like the row numbers, starting from 0 to 5. Next, we move to df.info method. This method is used to get quick assessment of the characteristics data frame, such as data types, missing values, and memory usage. It's often one of the first commands you might use when exploring a new dataset. It also gives an overall understanding of the structure and size of your data frame. If you see here, there is column named as unnamed 0, which has values from 0 to 5. In some cases, it might serve as unique identifiers for each row, kind of like IDs. In that case you might not need the index column because it's sort of duplicating information. But if you want to use the unnamed 0 column to use as the index column, you can add an attribute index_col equals 0 when you're reading your data into a data frame. This tells Python to use the first column as the index column. As a result, the unnamed 0 column disappears, and the first column becomes your new index column. Now, you've got 6 variables, with the first one representing the serial number or ID for each record in your data frame iris data sample. This is how we read a CSV file and also set the index column by specifying the column number. It's a neat way to clean up your data and make it more organized for analysis. Alright, let's now break down the process of handling special characters like question marks, hash symbols in your data using Python and Pandas. Please note that by default, Python considers blank values as nan, abbreviation of not in number, but it doesn't automatically interpret other special characters as missing values. However, if you're confident that these special characters indeed signify missing data and you want to treat them as nan, you can do so using Pandas. The first step is to identify the special characters using df.head function, and we see that the data frame contains special characters like question marks and hash symbols, alongside numerical values. These characters might indicate missing values in your dataset. Next, let us verify the count of nan values already present in the data frame, which we can do with command df.isNull.sum. In the output we see that sepal length cm column has 0 missing values, meaning there are no nan values. Sepal width cm, there is 1 missing value. Petal length cm, there is 1 missing value. Petal width cm, this column has 0 missing values. Species, there is 1 missing value. Now we will move on to replacing special characters with nan, as mentioned that Python automatically replaces blank values with nan. To extend this behavior to other special characters, like question marks and hash symbols, you can use the na_values parameter in Pandas read_CSV function. By passing a list of special characters to na_values, Pandas will interpret these characters as nan values while reading the data. After replacing the data with the specified na_values, Pandas will automatically replace all instances of question marks and hash symbols with nan. To ensure that the characters are correctly handled and standardized as nan for further analysis, use df. Head function again to read the first few rows with df. Head function, and now we can see that there are no special characters present in the data frame, and also if count the sum of nan value again, we can see that it has increased. In summary, by using the na_values parameter in Pandas, you can effectively handle special characters that denote missing values in your data and ensure consistency in how these values are interpreted and processed. Let's discuss into the details of reading Excel files using Pandas read_Excel function and how to handle special characters like question marks and hash symbols in the data. So, read_Excel is a command from the Pandas library that lets you read Excel files directly into Python. It's quite handy when you're working with data stored in Excel spreadsheets. When you use pd read_Excel, you just need to provide the file name with the .xlsx extension inside the function. For instance, if your Excel file has multiple sheets or tabs, and you want to access data from a specific sheet, you can use the sheet_name argument. This argument allows you to specify the sheet name from which you want to create a data frame. Let's say your Excel file has a sheet named iris_data, and you want to work with data from this sheet. You can use sheet_name equals iris_data inside read_excel command to access that specific sheet and store it in a data frame, like this. In this case I am using df1 as data frame. If you're not sure about the sheet names in your Excel file, you can check them using pd excel file, your_file.xlsx.sheet_names, which will give you a list of all sheet names in your Excel file. By following these steps, you can effectively read data from specific sheets in Excel files, handle special characters as missing values, and set the index column as needed for your analysis. Alright, let's dive into importing text-formatted data using the read_table command from the Pandas library. This command allows us to read text data into a data frame. All you need to do is give it the name of your file, like iris_data_sample.txt. Once you've run this command, now this data will be saved into Python, and it's stored in what's called a data frame. Think of a data frame as a fancy Excel sheet where you can see rows and columns of your data neatly organized. When you check your data frame, you'll see the name of your data frame size, which is something like 150 rows and 1 column. And we see that the text file has only 1 column, which is not correct. Now, here comes the interesting part. Sometimes, when you import your data, it might not look as organized as you'd expect. Maybe all your columns got squeezed into just 1 column. That's where delimiters come in. Delimiters are like separators that help Python understand where one piece of data ends and the next one begins. The default delimiter for read_table is the tab character, represented as \t, but if your data is using a different separator like commas or spaces, you can tell Python about it using the sep or delimiter parameter. But in this case, we can see that data is separated by blank space, so we will use the read_table command with delimiter blank space. Now we can see that our text data is neatly converted into 5 columns as in the case of CSV or Excel format. So, in this lecture, we covered the basics of importing various file formats for data analysis. We explored different file formats commonly used in data analysis, such as CSV, comma-separated values, Excel, and text files. Overall, we gained a good understanding of how to import and work with different file formats for data analysis purposes. These skills are essential for handling diverse datasets and conducting effective data analysis tasks. With this we will end this lecture here. We have seen some of the techniques of importing multiple types of data and handling special characters and replacing them with nan value. In our next video, we will continue our discussion on Pandas data frame. Pandas is a powerful Python library used for data manipulation and analysis. It provides data structures like data frames and series, along with tools for reading and writing data in various formats, handling missing data, and performing operations like filtering, grouping, and merging datasets efficiently. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more informative Python for data science content. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through Python's data science course. Thank you for watching and see you again.